Hi, I'm Jeremy Smith, Senior Manager of Software Development here at Rock Science, and today I'm going to show you a few key features of our latest program, RSSeismic. Okay, here's our landing page where you can create new projects, open our tutorials folder, or launch the Motion Manager module, which is sort of an independent tool to look at all your input motions. I'll start by creating a new project. And you can see on the left here, we have our main navigation pane where you can go between the different tabs in the program. To set up your project, all your options are here. You can set your profile generation to create profiles manually or automatically, and you'll get different options depending on what you select. You can set up your units, whether to create multiple profiles, and your analysis method. The three main analysis methods we have are linear, equivalent linear, and nonlinear. And this is the major driver of a lot of the different options in the program. Depending which analysis method you choose will affect a lot of the different options in the program. If we switch to nonlinear, we can see you have the most options. You can generate excess pore water pressure. Your solution type is set to time domain, and you can set up your default soil models and your default hysteric re-unloading formulation. So next we can look at our soil layers and soil properties and how they're defined. We can switch to the profile. Here's where you see your layers and your bedrock defined. You can add new layers. You can set the name of those layers and the thickness. And you can see that things update in real time. The soil properties is where you're going to define for each layer your basic soil properties, your soil model properties, and it's where you're going to do your reference curve and curve fitting analysis. There are a couple different ways to navigate between layers. You can click them in the view here, or you can select it with this combo box. And selecting the different properties will update the page on the right. Here we have one of our tutorial files that I've loaded. You can see all the layers defined here with the different properties. As I click through them, the graphs on the right update. I can also show the reference curve here. You can select between different models. And here's your curve fitting, where you can select different fitting procedures. You then press the fit button and you get this fitting limits dialog. We do the curve fitting, and we can see the results here of your curve fitting. If you're happy with the curve fitting, you can use the fit, and they will update the properties. In the soil properties, we have two other views. First is profile plots. Here you can visualize shear wave velocity, unit weight, and other properties as continuous functions with depth. This helps identify trends and anomalies in your soil data that might affect your analysis. The other tab we have is the advanced table view. This is a spreadsheet-like interface for entering layer thickness, unit weight, shear wave velocity, and other properties. This is useful for copy and paste operations from Excel. One of RSSeismic's brand new features is its seamless connection with RSLog. Let me show you how easy it is to bring in your data. So this is the import RSLog wizard. On the first page, you're going to log into your RSLog account. I'm going to put in the password. Here you can see all the projects that you have, and these are filtered to only include projects that have more than one borehole logged in them. You can see things like the project title, project number, what unit system they are in, and some other data to help you narrow down the project you want to use. So after you've picked a project that you want, you go next, and you're going to get a list of all the boreholes in that project. You can select all of it to import, or you can just select a few. After you've finished, if you've selected more than one, you are prompted to turn on multiple profiles if you haven't done that already. So once you click finish, you get a import success, tell you that you've imported your boreholes from RSLog, and you can see them in this list here. And switching between them, you can see all of the different profiles that you've imported. RSSeismic automatically converts the soil profile data, including layer thickness, unit weights, shear wave velocities, and some other properties. This is a big time-saving feature, and we have further integrations planned in our roadmap. Now let's examine the input motions view. This is where you can define the seismic loading for your analysis, and you can choose from your own motions or some of the included ones in the program. And I can select multiple ones to view here at the same time if I want to. You also are able to run some tools to process and validate your data. One such tool is the kappa estimator. This can be crucial for high-frequency ground motion characterization. Another tool we have is the time step reduction. Another such tool is baseline correction. And here you can correct your ground motion and save it as a new motion. The single motion view is where you can examine individual records in detail. You can see all the time history plots, the spectral plots, Fourier plots, and then you can drill down and see all of the exact data we're using to create these plots and the spectral data, which you can copy and paste into Excel. For nonlinear analysis, damping definition can be critical. RSSeismic offers sophisticated damping modeling that captures the complex behavior of soils under seismic loading. You can select from multiple hysteric damping models. The damping curves are automatically calibrated based on your soil properties, but you can also manually adjust them using our curve fitting tools. And on the right, you can plot frequency domain solution and your time domain solution. The compute options view is where you fine-tune your analysis parameters. Depending on your analysis method, you'll see different options enabled here. For equivalent linear analysis, you'll set convergence criteria and maximum iterations. For nonlinear analysis, you'll configure time step sizes, convergence tolerances, and pore pressuring modeling parameters. You can also select if you want to output just for your surface or if you want to output your results at all layers or specific depths or specific layers. After you're happy with your compute options, you can run the compute. This will run all of the profiles and the motions that you've selected. Once the compute is done, we can go and look at the results. So let's explore the comprehensive results that RSSeismic provides. Each view gives you different insights into your seismic analysis. We have the time history plots. You show the ground motion at each layer over time. You can compare input and output motions, identify amplification effects, and assess the impact of soil nonlinearity. We have the stress strain plots, your spectral plots, profile plots. These display properties like acceleration, velocity, and displacement, and how they vary with depth, helping you understand the vertical distribution of seismic effects. The other results views we have are the mobilized stress view, and here's where you can animate your displacements. You can see over time how your soil layers are displacing. We also have the response spectra summary, and this is per motion that you've done. And finally, if you've run a equivalent linear analysis, you can check the conversions for each of those. All results can be exported to Excel, and the interactive plots allow you to zoom, pan, and explore your data in detail. We also have our own report generator functionality. So the report generator can generate a report you can save as a PDF, HTML, or doc file. You can quickly navigate through the different results and input data, and you can see that the images of all the charts have been automatically put into the report. Thanks for watching. If you have any questions, please comment below, and don't forget to like and subscribe.